question that uh, feels like a real head-scratcher at first glance, pulled straight from the notes and sources you shared with us. It's about light, those tiny packets of energy we call photons.
Right.
We definitely know they carry energy. I mean, you feel the sun's warmth, solar panels work because of it, our eyes detect it. It's obvious.
Absolutely. Light-carrying energy is, well, fundamental to our experience. We see it everywhere, every day.
Right. But here's the puzzle, the tricky part. Physics also tells us photons have zero mass. Zero.
Correct. No rest mass.
And if you've ever heard of EMC, well, that famous equation seems to tie energy directly to mass. E equals mc squared.
It does seem that way, doesn't it?
So how can something with no mass,
Hmm.
how can it have energy? It just feels like a contradiction.
It really does. And yeah, it's a point of confusion for a lot of people. But your sources, they actually lay out a really clear path through this apparent paradox.
Okay, good. That's exactly our mission for this deep dive then. Using your material, we're going to unpack this.
Dig into it.
Yeah, show how it's not a contradiction at all, but actually fits perfectly within a more complete understanding of Einstein's physics. We need to look beyond just that simplified EMC far view.
Exactly. To see the full picture of what energy really means, especially for something as unique as, light.
So let's start right there with EMCA. Your sources dive into this first thing.
They do. And they're quick to point out that this equation, famous as it is, it's just part of the story.
Yes, that's a key insight right off the bat. EMC-MCO is a specific, you could say simplified version of the energy-mass relationship. Hugely important, yes, but it doesn't cover every single case.
What EMC-MCO specifically describes is the rest energy of an object.
Rest energy, okay?
This is the energy an object has simply because it possesses rest mass, and critically, when it's completely motionless, at rest.
Rest mass, okay.
Yeah.
Unpack that a bit more. What exactly do we mean by rest mass?
Think of it as the intrinsic stuff an object is made of. Its fundamental resistance to being accelerated when you try to push it from a standstill.
Like inertia? Sort of.
Very much related, yes. Your sources use the classic example. A bowling ball. It has significant rest mass.
Right. Takes effort to get it moving.
Exactly. And it has energy locked up in that mass, even when it's just sitting there perfectly still on the rack. That's its rest energy.
So rest energy is just the energy equivalent of that rest mass, the energy it contains just by existing, before it even moves an inch.
Precisely. Energy bound up in its mass when the object is completely at rest. Now let's contrast that with photons.
Okay, which the sources describe as fundamentally different from things with rest mass, like bowling balls or even, say, tiny electrons.
They really are. The crucial point is that photons are never at rest. Never.
Yeah.
They are created already moving at the speed of light, and they always travel at c in a vacuum. There's just no state where a photon is sitting still.
They only stop when they're, absorbed?
Right. They cease to exist when they interact and get absorbed. They don't have a still state.
And because they are never at rest, that whole concept of rest mass, well, it doesn't really apply to them in the same way it does to something that can be still.
Exactly. The material you provided is very clear on this. Photons have zero rest mass. Absolutely zero.
Okay.
And this isn't just like a definitional thing. As the sources explain, there's a deep reason linked to relativity. If photons did have any rest mass, even a tiny bit, it would take an infinite amount of energy to accelerate them to the speed of light.
But they're already at the speed of light.
Exactly. From the instant they exist. So they simply cannot have rest mass. It's incompatible with them traveling at c.
Okay, that makes sense. So EMCSNI is about rest energy from rest mass. Photons have zero rest mass because they're never at rest and couldn't be at c if they did.
You got it.
So if their energy isn't coming from mass in that specific even CS sense, where is it coming from? This is where the sources seem to shift our perspective, right?
It's the critical pivot point in understanding this. Energy isn't only tied to rest mass. That's just one form. Energy is also intimately tied to motion.
Motion, like kinetic energy, the energy something has because it's moving.
Yes, kinetic energy is part of it. But more fundamentally, it's tied to momentum.
Momentum. Okay, I remember that from physics class. Mass times velocity, kind of the oomph something has.
Exactly. That's a good way to put it. It's a measure of an object's motion, how much oomph it has, how hard it is to stop. Now, for objects with rest mass, like, say, a baseball, Their total energy is actually a combination of their rest energy from their mass and their energy of motion, which is directly related to their momentum.
Okay, so a baseball sitting on the plate just has rest energy.
Right.
But a baseball flying through the air after being pitched has that same rest energy plus extra energy because of its motion, its momentum.
Precisely. Total energy equals the rest energy plus the energy of motion, which comes from its momentum.
Got it. And here's where it gets really, really interesting for photons, according to the sources. Since they have zero rest mass.
All their energy, all of it, must come from their motion, specifically from their momentum.
Okay, so they completely lack that energy locked up in static stuff part, the rest energy bit.
That's correct.
But they do have the energy of motion part, and the sources are really clear. Even without mass, photons absolutely do possess momentum.
They do. It's a measurable thing. The material mentions the example of a solar sail.
Like in space, pushed by sunlight.
Exactly. That pressure from sunlight isn't some kind of magic. It's the constant transfer of momentum from countless photons hitting the sail. It's physical proof that light carries momentum, even though individual photons have no mass.
So photons are kind of like pure energy in motion.
That's a really good way to think about it, yeah. Or pure momentum, in a sense.
Okay, so how does this fit back into Einstein's theories? Is EMC dice wrong then, or incomplete?
It's not wrong, just incomplete for describing everything. Your sources explain that Einstein's work includes a more complete, a more general relationship. It connects total energy, rest mass, and momentum all together.
A bigger equation.
Essentially, yes. We don't need to get bogged down in the exact math, but the core idea is crucial. This fuller picture shows that the total energy of any particle or object relates to both its rest mass and its momentum. Think of it like energy can come from two sources.
Okay, so total energy depends on potentially two ingredients. A mass ingredient and a momentum ingredient.
Exactly. You can have energy from mass or from momentum or from both. Now think about how this applies specifically to photons.
Right. Their rest mass, the m in EMC, so is 0.
Right. So in this more complete energy equation, the part that's related to rest mass, it just becomes 0 for a photon. It vanishes.
So if the mass ingredient drops to 0, then according to this fuller theory, all the photon's total energy must come from the only other ingredient left.
The part related to its momentum.
That connects the dots.
It's the beautiful resolution, really. A photon's energy is directly and entirely tied to its momentum. Because it's constantly moving at c and it demonstrably carries momentum, it inherently carries energy.
So EMC tau isn't wrong.
Not at all.
It just describes a specific case where momentum is 0 when an object is at rest.
Exactly. For photons, the rest mass is 0, so the full energy equation simplifies in a different way, leaving only the momentum term contributing to its energy.
Okay, I think I'm following that. It's how can have energy without mass.
No.
But then, where do the...
And it drops down to a lower energy level. That energy difference has to go somewhere. It isn't lost. It's emitted as a photon.
And that photon carries away exactly that amount of energy.
Exactly that amount of energy, and the corresponding amount of momentum needed for it to travel at c.
Or the sources mentioned, like powerful events like nuclear reactions.
Right. Nuclear fusion or fission releases enormous amounts of energy, often in the form of very high-energy photons, gamma rays. Again, the energy and momentum are transferred directly from the system undergoing the change to the newly created photon.
Okay, so the energy is imparted during creation.
And your sources add another really crucial layer here. A photon's energy is directly related to its frequency.
Frequency, like the color of visible light.
Or for other electromagnetic waves.
Exactly like the color. Higher frequency light, which means shorter wavelengths like blue light or ultraviolet or X-rays.
Yeah.
These consist of photons that individually have more energy and more momentum than photons of lower frequency light, like red light or infrared or radio waves. So the bluer the light, the more energetic each individual photon is.
That's it. The frequency tells you exactly how much energy and momentum each photon is carrying. It's quantified. EEHF, Planck's equation.
That's incredible. Just thinking that the energy is literally encoded in how rapidly the electromagnetic field is, well, oscillating.
It is pretty amazing. And the sources offer a really helpful analogy here to grasp this idea of energy without mass.
Oh, yeah. What's that?
Picture energy existing in a purely motional form, like a wave in the ocean.
Okay, a wave. like rolling into shore.
Right. Now, that wave clearly has energy, doesn't it? It can knock you over. Definitely. It has energy because it's moving, it has height, it has momentum. The energy is in the dynamic motion of the water itself.
Okay.
But the wave itself isn't some separate, distinct chunk of static mass that's riding on the water. You can't isolate the wave mass. The energy is part of the moving structure, the pattern of the water.
Ah, I see. The energy is in the sloshing, the up and down, the forward motion of the water.
Yeah.
Not in some distinct wave stuff that has mass on its own.
Precisely. And your sources suggest thinking of a photon in a similar way as an energetic motion or an excitation, a vibration of the electromagnetic field itself.
Like a ripple in that field.
Kind of like a ripple, yes. Its energy is intrinsically linked to its state of motion, its frequency within that fundamental field. It doesn't need its own separate mass baggage.
Okay, wow. Okay, let's try and bring this all together then, synthesizing everything we've walked through from the sources.
Right. So, EMCI says that describes rest energy, the energy locked up in rest mass.
From something sitting still.
Exactly. Photons, on the other hand, have zero rest mass and are always moving at light speed. So their energy just doesn't come from that specific rest mass mechanism. Instead, their energy comes entirely from their momentum, from their motion.
And crucially, this isn't some weird loophole or a contradiction with EMCO.
Not at all. It fits perfectly within the broader, more complete framework of Einstein's theories on energy, mass, and momentum. That framework accounts for energy arising from momentum as well as from rest mass.
So for photons, because the rest mass part is zero, the energy equation just simplifies differently, leaving only the momentum contribution.
You've got it. It's a different but equally valid way for energy to manifest in the universe. It shows the richness, really, of what energy actually is.
It really does broaden the perspective beyond just mass.
Yeah.
That is truly fascinating.
It is.
So the core takeaway is pretty clear then. Photons have energy because of their momentum. That momentum is a direct result of their constant motion at light speed and the energy imparted during the event that created them. And this doesn't break physics. It actually reveals a deeper layer of how energy, mass, and motion are intertwined, going beyond just the simplified Eve-Sink equation.
Exactly right. It's a more nuanced picture.
Okay. Well, to leave you, our listener, with a final thought from the sources to maybe mull over, think about how light, this thing that seems so simple, so familiar, that we interact with constantly, how it embodies energy, not as trapped stuff that has weight and sits there, but as pure inherent motion, as vibration and excitement within the universe's fundamental electromagnetic field. And consider this, the very color of light that you perceive with your eyes.
Red, blue, green.
Yeah, that color is a direct fundamental measure of the energy and the momentum carried by each individual photon that's hitting your retina. It's energy made visible, in a way.
A very cool thought to end on.